My name is Luke Waltz. I'm a second-year PhD student in the Department of Food, Agricultural, and Biological Engineering. A lot of people try to use AI in agriculture. It seems like they're working with maybe smallish data sets that don't have a lot of diversity to them. I don't think we've seen a really large multimodal data set that's put together. So part of, I think, what's valuable about it is just the effort we put in to get all the different types of data combined that are annotated with both position and time. Diversity in our data set means that, just like I have sight and smell and touch and hearing helps me perceive my environment around me, the multiple modes of data helps us understand what's happening with the corn and soybeans. So the drone data overhead gives you one perspective. A smartphone, while it's still an image, gives you another perspective close in. And the soil data that you're looking at in the ground also gives you an additional perspective. So those multiple modes help you get a better perspective on what's happening to the corn and the soybeans. We've seen some early results with some of our time-lapse imagery where we calculated the uniformity of emergence of corn and soybeans. So corn in particular there's a correlation between how uniformly it emerges and the final yield. We've also seen the correlation between our soil volumetric water sensing and matrix potential relative to the precipitation across the 3 sites. Our goal here is to be able to really look at how can we be more accurate at yield estimation. Another one was growth stage. So could we classify growth stage of corn and soybeans, which is really important for both fertilization as well as weed pressure or herbicide or fungicide application. The data set is complete. The remainder of the project will be really trying to build those algorithms, tune them, figure out which hyperparameters work best in the model so that we can prove that we can estimate those things with some accuracy that would be valuable for a farmer. Our aspiration is to really provide science that can help the farmer be more precise. It's a really challenging problem in agriculture because there's so many variables that affect yield, right, from year to year, right, and from field to field. And so the research that we're doing this year is really helping to get at that, how to help them be more precise in their inputs.